All right, we're going to go ahead and talk a little bit more about the elimination method for solving systems of equations. So just to go over elimination, the definition of the elimination method is it is a method for solving a system of equations that involves adding or subtracting the equations to eliminate a variable. Sometimes both sides or of one or both equations must be multiplied by a number before adding or subtracting. So I just want to talk through this again. So we started out by just solving equations that had one variable, like this. We had 5y equals 20. Well, for that, I know in order to solve this equation, I need to isolate my variable. I need to get my variable all by itself, get the y all by itself. So in order to do that, I need to undo the operations that are here. So I know you can't see it, but there is an invisible multiplication sign in between that 5 and the y. So in order to undo that multiplication, I need to divide. So I divide both sides by 5, and I get y equals 4. Pretty easy. But now we're starting to deal with equations that have two variables. So for example, I have 6x plus 5y equals negative 20. When I have this, it's a little bit more difficult to figure out the answer to one of the variables. So what we can do is we can solve for one variable, but it's always going to be in terms of the other variable. So for example, if I wanted to solve for y, I'd get rid of this 6x, so I'd subtract 6x here, subtract 6x there, and I'd get 5y equals negative 20 minus 6x. And then to solve for y, I'd have to divide by 5, divide by 5, divide by 5, and I'd get y equals negative 4 minus 6 over 5x. And I mean, that's fine, it works, but it's not very clear. We still don't really have a clear idea of what y is equal to. And that's where this system of equations kind of comes in. When we have two equations, each with two variables, we can use them together, we can have them work together in order to solve for each of the variables. So let's use this equation. So 6x plus 5y equals negative 20. And I'm going to add another equation in here, which is going to be negative 6x minus 10y equals 25. So in the elimination method, remember, we are going to add or subtract the equations in order to eliminate one of the variables. We want to eliminate one of the variables because, as we could see, it's much easier to solve for one variable than it is for two. So what I'm going to do here, I can see that if I were to add these two equations together, the 6x and the negative 6x would cancel out, and I'd end up with 0. And then I'd be able to really easily solve for y. And then I use that value of y to plug back into one of my original equations, and then I can solve for x. So let's go ahead and do that. So I'm going to add these two together. So 6x plus negative 6x gives me 0. 5y plus negative 10y gives me negative 5y equals negative 20 plus 25 gives me 5. Well, 0 minus 5y is just equal to negative 5y. And again, that's equal to 5. Again, there's that invisible multiplication going on between the negative 5 and the y. So in order to undo that multiplication, I need to divide. So I divide by -5, divide by -5. And then these -5s cancel out, and I'm left with just y equals 5 over -5. But 5 divided by -5 is just equal to -1. So -1 is my answer for y. And now what I can do is I can take that -1 and I can plug it in to either one of these equations and solve for x. So let's use that first equation, 6x plus 5y equals -20. And since I know y is equal to -1, I can plug -1 in here. So now I get 6x plus 5 times -1 equals -20. Now I can simplify 6x. 5 times -1 is -5 equals -20. I'm going to move my -5 over to be with the -20. So I just add 5 here, which means I add 5 there. I added 5 on this side so that they would cancel out. So this ends up to be 0, and I'm left with just 6x equals -20 plus 5. -20 plus 5 is -15. And now I need to undo this multiplication. So I divide by 6 over here, divide by 6 over here, and x is equal to -15 over 6. Now what I can do is I can plug those answers back in to my original equations to double check my work. So let's give that a try. So we've got, where am I looking? So I've got 3a. Yeah. So let's plug in -15 over 6 for x and -1 for y in that first equation. 6x plus 5y equals -20. So I'm going to check to see 6 times -15 over 6 plus 5 times -1. Does that equal -20? Let's see. So 6 times -15 over 6 gives me, so these 6's will cancel out and I'll be left with just -15. And then 5 times -1 is -5. Yes, that does equal -20. And then let's plug it into that second equation. So I have -6x minus 10y equals 25. -6 times -15 over 6 is my x value minus 10 times -1 is my y value. Is that equal to just positive 25? Well, -6 times -15 over 6, the 6's cancel out, and I'm left with negative times a negative. It's equal to positive 15. And then minus 10 times -1 is -10. Well, 15 minus a -10 is the same thing as 15 plus 10. And yes, that is equal to 25. So I know that this is my answer. -15 over 6 is equal to x, and -1 is equal to y. I write my answer as an ordered pair. Remember, x comes first and then y. So x is -15 over 6, and y is -1. And that will be my answer. So now what we're going to do is we're going to look at an example where we're going to have to multiply either both or one of the equations by a number before we can add or subtract. So I'm just going to write down an example and I'll be right back. All right, so we're going to look at a real-world example that can be solved by using elimination. So The Montague family and their neighbors, the Capulets, attended the school play together. The Montagues bought 2 adult tickets and 3 student tickets for $16. The Capulets purchased 3 adult tickets and 2 student tickets for $19. We want to find out how much does an adult ticket cost and how much does a student ticket cost. We're going to do that with 3 steps. So first we're going to write a system of equations in standard form for this situation. Then we'll use elimination to solve the system of equations. And then finally we'll check our solutions to make sure we got it right. So first thing we're going to do is write a system of equations for this situation. So we have adult tickets and we have student tickets. And we have the number of each kind of ticket that was bought. And we have the totals that each family spent on tickets. So let's look at the Montague family first. So they bought 2 adult tickets and 3 student tickets. Let's call our adult tickets A. And our student tickets S. So they bought 2 adult tickets, 3 student tickets, and when we added up the price, it equaled $16. So therefore, we would have 2 times A plus 3 times S equals 16. 2A plus 3S equals 16, right? Now, for the Capulets, we'll use the same variables, A for adult ticket, S for student ticket, and I want you guys to give it a try writing out your own equation for the Capulets. So you can pause this video. Remember that the Capulets purchased 3 adult tickets, 2 student tickets, and they spent $19, right? So pause the video, try and write your equation, and then come right back. So when we are writing the equation for the Capulets, again, we have 3 adult tickets that we want to buy and 2 student tickets that we want to buy. These variables are standing in for the price per ticket, the price of 1 ticket, okay? So if I were to buy 3 adult tickets and A was equal to the cost of 1 ticket, then I would need to multiply A by 3. So it's going to be 3A plus 2 times the cost of a student ticket, so 2S, and that equals 19. Therefore, my system of equations, the 2 equations working together here, are 2A plus 3S equals 16, and 3A plus 2S equals 19. So now we're moving into part B, where we're going to use elimination to solve this system of equations. Again, we have to use some kind of method to solve this. We can't just go through and solve for A, because it would always be in terms of S, and we don't know what S is equal to either. So we want to use this elimination method to first eliminate one of the variables so that we can solve for the other one. So the elimination problems we've looked at so far, we've been able to just add or subtract the 2 equations, and in doing that, we eliminate one of the variables. However, you might be able to tell that for this system, we can't do that. If we add these 2 equations together, I'd get 5A plus 5S equals 16 plus 19, which is 35. And I'd still be in the same boat where I have two different variables and I don't know the value of either of them. So that's not going to be an option. Same with subtracting. If I tried to just subtract, I would get 2a minus 3a is negative a, and 3s minus 2s is s, and that again equals 16 minus 19, which is negative 3. But again, I have an equation with two different variables, both variables I don't know the value of, so this doesn't help me. So remember, our goal here in using elimination is to eliminate one of the variables. So what we can do, you might remember from that definition of the elimination method, what we can do is multiply either one or both equations in order to eliminate a variable. So what we're going to do is we are going to take a look at the coefficients here. So if I wanted to eliminate a, I would need these two numbers to be additive inverses of one another. So it would need to be negative 6 and 6, or negative 2 and 2. And then that way they would cancel out and I'd be left with only the other variable. Okay, so in order to eliminate these variables, again, I'm going to multiply by a number so that I can change these into their additive inverses. Okay, and let's just decide we're going to eliminate the a first. So if the coefficient of this one is 2 and the coefficient of this is 3, I need to first think about what could I multiply by both of those numbers so that the product, the answer, would be the same, or would be the additive inverse. Have a think about that for a second. You can pause the video. We'll come back and discuss. So I know that if I multiply 2a by 3, I would get 6a. And if I multiplied 3a by negative 2, I would get negative 6a. 6a and negative 6a cancel out, which is exactly what I want. So we're going to give that a try. So I'm going to multiply this first equation by 3, the whole equation. So 3 times 2a plus 3s equals 16. 3 times 2a is 6a. 3 times 3s is 9s. 3 times 16 is 48. And I'm going to multiply this one by negative 2. So that was negative 2 times 3a plus 2s equals 19. So negative 2 times 3a is negative 6a. Negative 2 times 2s is negative 4s. Negative 2 times 19 is negative 38. And now I have this new system of equations. And I say it's new, it's really the same thing. It's the same thing, but it just looks a little different. And it's more useful to me now. because I can add these two equations together and I'd be able to cancel out one of my variables. So if I add these two together, 6a and negative 6a gives me 0. 9s minus 4s gives me 5s. And 48 plus negative 38 is equal to 10. 0 plus 5s is just equal to 5s. And again, that's equal to 10. In order to solve for s, I need to divide both sides by 5. So s is equal to 2. Take a moment, pause the video, think about what our next step is going to be. Think about what our next step will be. So we're going to take this solution to one of our variables, and now we're going to plug it back in to one of our original equations. We can plug it into either one. And then we're going to solve for the other. So I solved for s, now I want to solve for a. So I'm going to use this first equation, 2a plus 3s equals 16. And now I'm going to plug in 2 for s. So 2a plus 3 times 2 equals 16. 2a plus 3 times 2 is 6 equals 16. I want to get this a all by itself. So first I need to get rid of my 6. So since I'm adding 6 here, I need to subtract 6 to get rid of it. 2a, these guys cancel out, and that's equal to 16 minus 6 is 10. Now I need to divide this side by 2, divide this side by 2, and I'm left with a equals 5. A equals 5. So we just went through parts A and B. Now we need to do C. We need to check our solutions. So let's first check this first equation. 2a plus 3s equals 16. A is going to equal 5. So 2 times 5 plus s is going to equal 2. So 3 times 2. Does that equal 16? Let's see. 2 times 5 is 10. Plus 3 times 2 is 6. Yes, that does equal 16. So that one works. Now let's check our second equation. 3a plus 2s equals 19. A is equal to 5. S is equal to 2. So I get 3 times 5 plus 2 times 2 equals 19. 3 times 5 is equal to 15 plus 2 times 2 is equal to 4. Yes, that does equal 19. So we're correct. So the cost of a student ticket is $2. And the cost of an adult ticket is $5. Right? So I'm going to post a couple of practice problems that I want you guys to work on. As always, if you have any questions, please reach out. I would love to hear from you. Thanks a lot for watching. Hope you're having an awesome day.